Okay, so this is a revision video, and this one is on the topic of algorithms. So what I'm going to do is I'm going to have a look over the past 7 years of all the algorithm questions that have come up. Now, the first one is just general algorithms, and there's only been 2 questions on these, but I know that in the past they haven't done brilliantly, so we're going to go through how to do them. So if we have a look at this, I'm going to have to split the screen in 2, but we've got a flowchart algorithm here. Now, whenever you get a flowchart, we need to use this thing. Oh, sorry, we need to use this thing over here, which is our trace table. And all we do is we're going to get judged on the stuff that we put into our trace table. Um, so this is our flowchart, and this is the first question. So an algorithm is described by the flowchart shown in Figure 4. Given that S equals 25,000, complete the table in the answer book to show the results obtained at each step when the algorithm is applied. So we've got S equals 25,000, and then we've just got to put that in and then see what we get out. So we've got to complete the table. So let's do that. So the first thing, we have to start, and it says input S. So S is 25,000. Then T equals 0. R equals S take away 8,000, so we do that. So that's going to be 17,000. Is R greater than 0? Yes. So what we're doing is we're going down through this. So we've done input S, we've put T equals 0. We've done R equals S take away 8,000. We then get to a decision. Is R greater than 0? Yes. So we go down. So T equals 0.2R. So we multiply R by 0.2. So if we do that, 0.2 times 17,000, and we get 3,400. And then the next thing, so that's that one. We keep going. R equals R take away 10,000. So we take away 10,000, so that's going to be 7,000. Is R greater than 0? Well, yes, it is. So I should say yes. What the hell happened there? Okay, so T equals T plus 0.15R. So it's going to be 3,400 plus 0.15 times by a new value of R, which is 7,000. So 3,400 plus 0.15 times 7,000. And we get T is 4,450. R equals R take away 12,000. So if we take away 12,000, it's going to be minus 5,000. Is R greater than 0? No. So with no, we then follow it this way, and we output T. So T is 4450, then end. And that's it. All we've done is we've just followed it from the start up here down to the end here. And as long as you sort of take your time over doing it, these questions aren't that bad. So the algorithm is designed to model a possible possible system of income tax T on an annual salary of S. So we said that S was 25,000, so that means that the salary is 25,000. It's important to sort of try and understand what it is that they're asking you here. So they're telling you that the salary is 25,000 and T is the tax. So write down the amount of income tax paid by a person with an annual salary of 25,000. Well, we just worked that out. T is the tax, so 4,450. So really straightforward. Find the maximum annual salary of a person who pays no tax. So therefore, if they pay no tax, then what that indicates that T equals 0. So if we have a look at our flowchart back here, when do we start accruing T's? So here, we've got T equals 0, so we haven't accrued any tax so far. This is the first point here, where we get tax. So we've got our input S, which is our salary. R equals our salary, take away 8,000. So what we want is we want to avoid this one here. So we want to take the no path. So we want R not to be greater than 0. So the way we get r is we do r as s take away 8,000, and we don't want that to be greater than 0. So if we have s as 8,000, t equals 0, r is s take away 8,000, so 8,000 take away 8,000 is going to be 0. Is r greater than 0? No. So we've got taxes 0. That's it. That's the maximum salary of a person who pays no tax. Also, you could have like 7,800. And if we had 7,800, that's what we'd input for s, and then t equals 0, r equals s take away 8,000, so that's going to be minus 200. So we still have no and 0. That isn't the maximum. The maximum value of of s that we could have is 8,000. So that when we take away 8,000, we're left with r equaling 0. So it's more a case of being able to understand what these flowcharts show, as opposed to anything else. So that's that. And if we just check our answers, I believe. Mark scheme. So yeah, minus 5,000, 4,450, 4,450, and 8,000. Okay, so the next question that we're going to be doing is the only other flowchart question that they had. So let's get rid of the ink there. And this is our flowchart this time. So here, what an awesome name! Hero's algorithm for finding a square root is described by the flowchart in figure 1. Given that n equals 72 and e equals 8, so the first thing we've got to do on our flowchart is input n and e. So we're going to input n as 72, and we're going to input e as 8. And this is for finding a square root. Again, it's always worth keeping in the back of your mind what it is that we're actually doing here. And once we've inputted these, we've got to use the flowchart to complete the table in the answer book. Work into at least 7 decimal places again. Make sure you read the question. 7 decimal places when necessary. Give the final output correct to 7 decimal places. Okay. So let's work through it. So we've inputted n and e. R equals n divided by e plus e divided by 2. So if we do that, 72 divided by 8 plus 8 divided by 2, and we get r as 8.5. Okay, is r take away e in between 10 to the minus 6, so minus 10 to the minus 6 and 10 to the minus 6. Okay, it might be worth clarifying this a little bit more. Minus 10 to the minus 6 is going to be minus 0 0.0, 10 to the minus 6 is 0 0.0000001. Sorry, not 6. So this is 10 to the power of minus 10 to the power of minus 6, and this is 10 to the power of minus 6. So we want to know when we do r take away e, we get 0 0.5. So no, that's not in between 0 0.00000 minus 1 and 0 0.0000001. So the answer is no. So then e equals r. So we've got r is 8.5. And then we go back to this one. So now r equals n divided by e plus e divided by 2. So we're going to do 72, that's what n is, divided by 8.5 plus 8.5 divided by 2. And we get, remember we're doing this to 7 decimal places, so 8.4852941. And if we take them away, r take away e gives us 0.0146 7. So the answer to that is no. Right on top of that. No. Okay, so now we let r equal, so it's no, so it's going to be equals r. So e equals 8.4852941. So 8.4852941. So 72 divided by, oh, excuse me a sec. Okay, so I just have to check the mark scheme to see if it works, if you've rounded to 7 decimal places, or whether or not they want the original answer. But they're okay if you do the rounding. So now if we do 72 divided by this answer here, plus that answer there, divided by 2, we get 8.485281374. So if we do that, take away our value, we get minus, so we get 0.0, so we get minus 1.27 times 10 to the minus 5. So we then let 8.485281374 as our next value v. Then we substitute that in. So if we substitute in this into this one here, so we're substituting in this value here as our value of e. Having a nightmare. There we go. Yeah, so substitute that's in as a value of e, so it's going to be 72 divided by this, 72 divided by this one here, plus that one there divided by 2. And we get 8, so this should be in the box above, 8.485281374, which if we take it away, gets 0. So yes, there is in between minus 0.000001 and 0.000001. Because there's no difference between them. So again, all we've done there is we've just started off with 72 and 8, and we have gone through and just repeated this process until we get to here and we say yes. So now we output R. So we can say that R equals 8.485281374. Okay, so the flowchart is used with n equals 72 and equals minus 8. So if we have a look at minus 8, and if we do the first one, so we do 72, so we are using 72 and e is minus 8, so 72 divided by minus 8 plus minus 8 divided by 2 gives us minus 8.5. So all it's going to do is going to do the same process, because it's the same digits, same process, except it's going to give us the negative square root. So describe how this would affect the output. It gives us negative square root. State the value of e which cannot be used when using this flowchart. So if we have a look at the flowchart, what value of e can't we use? And we can't ever divide where something's 0, so we need to find the value of e which makes the denominator 0. If you have a look at this here, it doesn't matter about what we add on, but here we've got n divided by e. We can't divide by 0, so e cannot be 0. And those are the only two questions on general algorithms that we've seen. So general algorithms and flowcharts, as long as you understand that we've just got to follow it and then write everything in the trace table step by step, then you know that you're going to get the correct answers.